Hello everyone. Let's start paper 2 of AS level chemistry, October-November 2025, variance 24. Question number 1 belongs to group 17. So this might be the easiest one. So group 17 elements are oxidizing agent. Oxidizing agent oxidizes another substances and reduces themselves. So explain how group 17 elements acts as an oxidizing agent. So oxidizing agent, halogens, causes another substance to be oxidized and reduces themselves. Write an equation to show the reaction in which chlorine oxidizes aluminum metal. By the way, according to my redox lecture in theory classes, I've told you all metals are reducing agent. So technically, aluminum metal is a reducing agent, and chlorine is basically an oxidizing agent, which is why reaction is going to be redox. So I'm going to write equation like this. This is aluminum reacting with chlorine, converting into aluminum oxide. Oh, aluminum chloride, my bad. Okay, so that's the equation. A student heats equal amount of iodine and hydrogen gas in a sealed flask. So when hydrogen gas reacting with iodine gas, so it will turn to hydrogen iodide gas. See, hydrogen is colorless, Hi is colorless, but iodine is purple in vapor form, all right? So when students leaves the content to cool, so when you decrease the temperature, obviously this gas will turn to liquid or solid, which means during the reaction, color observation would be purple to colorless, okay? Or violet to colorless. Violet to colorless observation. Because when you cool down the content, which means you are decreasing the temperature, if you decrease the temperature, obviously gas will turn to liquid or even solid. So obviously this violet color turns to colorless, okay? Chlorine and bromine can each react with ammonia to give nitrogen and hydrogen halide. Now, halogen could be chlorine or bromine. The relative bond strength determine the difference in the enthalpy change of the two reactions. Describe and explain the difference in the halogen bond strength of chlorine and bromine. So that's easy. Chlorine has smaller atomic size. Bond length decreases. And orbital overlapping is going to be more, all right? Bromine, on the other hand, has larger atomic size. Consequently, bond length increases. So orbital do not overlap to the maximum extent. Mhm. Reduce the thermal stabilities of hydrogen halide and hydrogen bromide. So obviously HCl is more thermally stable than HBr. Okay, define enthalpy change of formation. Enthalpy change occur when 1 mole of compound is decomposed. My bad. When 1 mole of compound is formed from its constituent elements in their standard states. Okay. So we don't need to write under standard condition because examiner is not looking for the standard enthalpy change of formation. Okay. He hasn't written standard key term, which means we don't need to respond in terms of standard enthalpy, a standard condition. So we don't need to respond the definition in terms of standard condition because examiner has not written the standard terminology in the definition. Okay. I hope it makes sense to you. Table 1.1 gives data relevant to the reaction of chlorine with ammonia. Use the data in table 1.1 to calculate the enthalpy change of the reaction of chlorine with NH3. Okay, let me write down the equation first. This is ammonia, this is chlorine. They are reacting together, converting into HCl plus nitrogen. And we need to find out the enthalpy change of this reaction also. And since the formation data is given, which means Haseloff cycle needs to start from constituent elements. So I need nitrogen, I need hydrogen, I need chlorine. And for this, arrow needs to be upwards. Okay, the enthalpy change of formation of ammonia is given, which is minus 46. Since we have 2 mole in the equation, so we need to multiply by 2. The enthalpy change of HCl is given in the equation, which is, in the data, which is 92. Since we have 6 moles, so we need to multiply by 6. We need to draw a clockwise arrow in the thermochemical Haseloff cycle. By the way, standard enthalpy change of formation of diatomic molecule is always 0, which is why examiner hasn't given any value here for chlorine and nitrogen. So we need to ignore chlorine and nitrogen from our calculation. So these two values has to be positive and this value has to be negative, and we need to equate them with 0. So let me write it down. Standard enthalpy change of reaction plus minus 46 times 2 minus 92 times 6 equals to 0, because we need to find the value of delta HR, enthalpy change of reaction. So enthalpy change of reaction from this is going to be minus 460 kilojoule per mole. I hope it makes sense to you. Okay. Let me cross check calculation. 6 times 2 plus 92 times 6. And 92 times 6. 552, 552, 552, 552. Yeah, minus 460. Okay. Iodine reacts with ammonia to form Ni3. Predict the shape of the molecule of Ni3. Explain your answer. Well, we have done ammonia in the class, so its shape is similar to ammonia. Oh, my bad. It's iodine. Iodine belongs to group 15 of the periodic table, which is why it has 5 valence electrons. 1, 2, 3, 4, and this one is 5. Around nitrogen atom, we have 3 single bond and 1 lone pair. So total is going to be 4. Whenever 3 single bond and a 1 lone pair, geometry is going to be trigonal pyramidal. And angle is going to be 107 degree. So shape is trigonal pyramidal. And angle is going information. This is because molecule contain 3 covalent bond and a lone pair. Okay. Next, table 1.2 shows some information about reaction of sodium chloride, sodium bromide, and sodium iodide. When silver ions are used, sodium chloride gives you white precipitates, sodium bromide gives you creamy precipitates, and sodium iodide gives you yellow precipitates. Okay. Observation with H2S, concentrated H2SO4. When treated with sodium chloride, you will get misty fumes or steamy fumes. With NaBr, let me write down the equation first. When sodium bromide is used and it is treated with concentrated sulfuric acid, initially it will turn to sodium hydrogen sulfate and misty fumes of HBr. Now this misty fumes of HBr is further treated with concentrated H2SO4, and as a result bromine is given off, which shows red brown color, along with sulfur dioxide and water. So I believe I'm going to write the color of bromine here in this scenario. So the color of bromine is going to be red brown liquid. And also sulfur dioxide gas is given off. So bubbles of gas. Okay. So I've done table 3, table 1.2 suggests the identity for the species that produces each observation in the reaction of sodium iodide with concentrated sulfuric acid. Black solid represents iodine. Yellow solid represents sulfur. And effervescence is basically sulfur dioxide or H2S, hydrogen sulfide in fact. And we have done this equation, right, in the class. Let me remind you some equations here. When hydrogen iodide is treated with concentrated sulfuric acid, it will turn to iodine that will give you black solid. H2S gives you effervescence with rotten egg smell, and then water. Okay. Uh, One more thing. When we use hydrogen iodide with concentrated sulfuric acid, we can get iodine plus sulfur, and sulfur shows yellow solid, and 4H2. So there are multiple equations for this concept, and I hope you get the point. So brown solid from here, yellow solid from here, and effervescence of rotten egg smell from here. Okay. Table 1.3 gives some information about magnesium chloride and SiCl4. Explain the difference between electrical conductivity of liquid MgCl2. Since it is liquid, I mean molten, so it has free mobile ions, and so it can conduct electricity without any issue. Okay. Now let me write down. Liquid MgCl2 contain free mobile ion, hence can conduct electricity. As MgCl2 is ionic compound. On the other hand, SiCl4 is basically a liquid. So refer to bonding and relevant particles in your answer. Okay. SiCl4 is a covalent molecule and non-polar. So due to the absence of free mobile ions, cannot conduct electricity. Suggest the pH of the solution that forms when each chloride is added to water. MgCl2 gives you a pH of 6.2 to 6.5. That's the range we have discussed about. SiCl4 gives you a pH of 0 to 3 or just 3. I've given you 3, all right, in the class. Okay. So that's the end of first question, I believe. Oh my goodness. Question number 2. Aluminum oxide and phosphorus 5 oxide, which is a formula of P4O10, are both used as reagent and catalyst. The melting point of aluminum oxide is 2072 degrees Celsius. The melting point of P4O10 is 340 degrees Celsius. I mean, the melting point of aluminum oxide is greater than P4O10. So explain the difference in the melting point of these two compounds. And I've told you in the class whether examiner has given us any sort of instruction or not, we need to respond melting and boiling point in terms of structure and bonding. So let me write it down. Aluminum oxide has a giant ionic lattice, giant ionic crystal lattice. So due to strong electrostatic attraction between ions, more energy is needed. Okay. P4O10, on the other hand, has a simple covalent molecule with weak van der Waals forces, or you can even write induced dipole, instantaneous dipole forces. So less energy is needed to overcome such force. Okay. Oh my goodness, that's a numerical. Okay. A 5 dm cube sealed flask, if it is sealed, which means dynamic equilibrium needs to be established. Uh, zero point 0.4 moles of carbon monoxide and 0.8 moles of hydrogen and an aluminum oxide as a catalyst. The flask is heated to a temperature of 290 degrees Celsius and allowed to reach equilibrium. That's the chemical equation. The equilibrium constant Kc is given. That's the equilibrium constant Kc की value is given. This concentration is cancelling out with this one, but this concentration cannot cancel out. So unit is going to be mole inverse to, oh my goodness, mole uh, inverse to dm6. I hope it makes sense to you. Okay. Let me show you how did I get that unit. The concentration of methanol is going to be mole per dm cube. The concentration of carbon monoxide is going to be mole per dm cube. The concentration of hydrogen is mole per dm cube, but because of a square, it's going to be mole squared dm minus 6. So unit is going to be mole per dm cube divided by mole cube dm minus 9. So when you cancel out these two units, obviously you are going to get this answer, okay? The equilibrium mixture contain 0.280 moles of methanol. Calculate the value of Kc. Give your answer to three significant figures. Okay. Let me write down the equation first. This is carbon monoxide plus hydrogen, and this will give you methanol. So the initial moles of carbon monoxide is given in the question, which is 0.4. The initial moles of hydrogen is given, which is 0.8. Obviously 0, 0. Over here 0, 0. And initially the amount of methanol we need to assume is 0 because reaction hasn't started yet, okay? So that's the initial value, initial amount of moles. All right. The reacted amount moles is going to be 0.280. Since carbon monoxide and methanol has 1:1 ka ratio, so the amount of reacted mole from carbon monoxide should be 0.280 moles, which is why methanol at equilibrium formed is 0.280. All right. So to get the moles of carbon monoxide at equilibrium, I need to subtract zero point 0.4 from 0.280. I'll get how much? 0.12 moles. So at equilibrium, the amount of carbon monoxide left is 0.12 mole. See, carbon monoxide and hydrogen has 1:2 ka ratio, right? So if 0.280 moles were reacted from carbon monoxide, let's find out how much amount of hydrogen should react during the reaction. So let me change the color so that you will get the idea. The molar ratio between carbon monoxide and hydrogen is 1:2. If 0.280 moles has been reacted from carbon monoxide, so the moles reacted from hydrogen should be twice, and 0.28 times 2 is going to be 0.56 moles. Okay. This means moles of hydrogen at equilibrium needs to be found out by using the initial value of 0.8 moles, and the reacted amount of hydrogen is 0.56. So the remaining amount at equilibrium of hydrogen should be 0.24 moles. Okay. So the amount of hydrogen left at equilibrium is 0.24, and the amount of methanol at equilibrium is already given in the question, which is 0.280. Okay. It has to be zero. It has to be zero. Now, the volume is given in the question, which means I'm going to use this volume to get the concentration of each reactant and product. So to get the concentration, 0.120 divided by 5, 0.12 divided by 5, I'm going to get 0.024, 0.24 divided by 5, so it's going to be 0.048, and 0.280 moles divided by 5, 0.28 divided by 5, it's going to be 0.056. So I've got the concentration of reactant and product. I'm going to plug in these values in the formula to get the answer. So I'm running out of space here. So what should we do? Let me write it down here. Kc equals to concentration of methanol is 0.056 divided by concentration of carbon monoxide is 0.024, and the concentration of hydrogen is 0.048 power square. So the concentration of Kc, the value of Kc is going to be 1.01 into 10 to the power 3. That's the value of Kc, guys. So examiner is looking for the 3 significant figures answer. And that's your answer, 1.01 into 10 to the power 3. Now next part is state and explain the effect, if any, on the value of Kc when the overall pressure is sealed in the sealed flask is increased. Well, Kc is only temperature dependent. So there will be no change in the value of Kc. Okay, so no change in Kc value, as Kc is only temperature dependent. Okay. P4O10 catalyzes the reversible reaction of carbon monoxide with hydrogen to form methanol. P4O10 then acts as a dehydrating agent, causing methanol to form dimethyl ether or methoxymethane. Explain how the presence of a catalyst affects the chemical reaction. Yeah, a catalyst uh, lowers the activation energy by providing an alternative pathway. Thus, rate of reaction increases, or thereby increases the rate of reaction. Construct an equation for the dehydration reaction of methanol to form dimethyl ether. So it's CH3OH is converting into CH3OCH3, and dehydration means loss of water. So I'm going to write H2 also. So we have 2 methyl, so we need to put 2 here. So how many hydrogen atoms here? 1, 2, and 1 oxygen. 2 hydrogen and 1 oxygen give you water, and the remaining 2 methyl and 1 oxygen gives you dimethyl ether or methoxymethane. Write an equation to show the reaction of P4O10 with the excess of water. When P4O10 is dissolved in excess water, you will get phosphoric acid. And the formula of phosphoric acid is H3PO4. Since we have 4 phosphorus on the left hand side, we need to put 4 phosphorus here. I'm going to write 6 here. So that's the balanced chemical equation. Okay, that's the end of this question, guys. Let's move on to the next one. That is question number 3. Propane 2-ol is sometimes added to fuel to help it burn. Figure 3.1 shows some reactions of propane 2-ol. Draw the structure of organic compound K. Okay. When propane 2-ol, which is basically a secondary alcohol, is oxidized, obviously you are going to get ketone. So that's going to be propanol. Since we have CH3CHOH group XR, which means I'll get the positive test of iodoform, which is why I'll get iodoform and salt of ethanoic acid. On dehydration, I'll get propene. So draw the structure of organic compound K. So that's propanol. This is CH3. This is CO. This is CH3. Okay. Or you can write in a skeletal form also, like this. Okay. State an observation you would make in reaction to. In reaction to, I'll get the yellow precipitates of iodoform. Okay. State the type of reaction that shows in reaction 3. So reaction 3 is basically dehydration. It is also called elimination. Since examiner has written dehydration, okay, we can write dehydration also. Complete figure 3.2 to show the pi bond in L that is formed from orbital overlap. So make a molecular orbital like this. We did in the class, right? If you remember. So that is the electronic cloud of pi bond. Okay. I hope it makes sense to you. Next is propane 2-ol reacts with sodium, produces this anion. These anions reacts with 2-bromopropane to form compound N as shown in figure this. So technically this is secondary alcohol, and secondary alcohol undergoes both SN2 and SN1. Alright? Write an equation for the reaction of propane 2-ol with sodium. That's an easy thing. Propane 2-ol is this. With sodium, it's going to be treated with Na plus hydrogen gas. I need to put 2 here, uh, and 2 here. Okay? Just to balance the equation. Or even you can write in 1 for 1 mole also. That's also acceptable, okay? The reaction 2-bromopropane with this anion follows SN1 mechanism. See, I've told you that secondary alcohol undergoes both SN1 and SN2, and examiner has given you clear instruction that you need to follow SN1 mechanism. And in SN1 mechanism, reaction takes place in 2 steps. So in the first step, carbocation is formed. So this is slight negative, this is slight positive. ये bond यहाँ से break हो जाएगा, and as a result you will get carbocation, which is going to be secondary carbocation. Okay, now this secondary carbocation reacts with this nucleophile, and as a result you will get this product. Okay, suggest how the rate of SN1 reaction would change if at all if 2-chloropropane were used instead of 2-bromopropane. Explain your answer. Well, in 2-chloro, that is a general representation of 2-chloropropane in which we have carbon chlorine ka bond. In 2-bromopropane, it's a so RBR is the general representation of this, and it has carbon bromine bond, and carbon chlorine bond is stronger than carbon bromine bond, which means if reaction takes place with 2-chloropropane, it's going to be slow. So let me write it down. Carbon chlorine bond in 2-chloropropane is stronger than carbon bromine bond in 2-bromopropane. So rate of reaction with 2-chloropropane would decrease. Okay. N is also added to petrol to make it burn more smoothly. Construct an equation for the complete combustion of N. Okay. So in complete combustion, I'll give you excess amount of oxygen, and as a result, we'll get carbon dioxide and water. Let me balance carbon and hydrogen. We have 6 carbon, so I'll put 6 here. We have 14 hydrogen atoms, so I'll put 7 here. Count how many oxygen atoms. 6 times 2, 12. 12 plus 7, 19. So it was a 16. 9 to 18. 6 times 2, 12. 12 plus 7, 19. So put 9 here. So 9 times 2, 18. 18 plus 1, 19 oxygen. Okay. That's the balanced chemical equation. That's question number 3. Let's start with 4. Compound P and Q are structural isomers of each other. Define structural isomerism. Compounds which have the same molecular formula. But different structural formula. P shows geometrical isomerism. Draw the geometrical isomerism of P. Explain why the two isomers are not identical. P. Uh, okay. So we have one hydrogen on this side and another hydrogen on this side. So two similar hydrogen pairs on the same side of the double bonded carbon atom, which means it is cis. When we have cis, obviously we are going to get trans also. Okay. And this is cis, so I'm going to write trans. Okay. So for trans, it has to be like this because hydrogen attached here now and this hydrogen attached here now. So both the hydrogen are diagonally attached with a double bonded carbon atom, which means it is going to be trans. So I think that's the answer. Okay. Let me check how many carbon atom we have. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's correct. Explanation. Geometrical isomerism arises because of the restricted rotation of double bond around its axis. Around its axis. Okay. Both P and Q reacts with aqueous bromine. Name the mechanism for this reaction. That's easy. Electrophilic addition reaction. Because all alkenes undergoes electrophilic addition reaction. Q is oxidized by hot concentrated acetate KMnO4, forming two different organic products. Construct an equation for this reaction using O2 represents an atom of oxygen from the oxidizing agent. My bad. That's an easy thing. And that's a different sort of thing. This is nascent oxygen, also called atomic oxygen. So when we have, double bonded CH, it will turn to CWH. Plus, when we have double bonded C, it will turn to ketone. All right. So how many oxygen atoms we have? 2 plus 1, 3. So we need to put 3 oxygen atom here so that we can balance the equation, okay? I hope it makes sense to you. Next, Q reacts with HBr to produces two structural isomers R and S as shown in figure. State and explain why isomer S is a major product of this reaction. So technically, we are going to get two different carbocations as a result of breaking of pi bond. The first one. So when we shift pi bond onto this uh, carbon atom, so obviously it's going to be, hold on a second, let me draw the structure and then we can decide. That gives you more precise explanation. This is CH3, this is CH3, this is double bond CH and then CH3. So that's the structure of alkene, and I'll get two different sort of carbocation from here. The first one is when we shift pi bond onto this carbon atom, so I'll get this carbocation. This is negatively charged, this is positively charged. When carbon has positive charge without hydrogen, it's going to be tertiary carbocation. Another breaking of pi bond has to be like that. That pi bond shifts onto that carbon atom. So I'll get CH3, CH3. Obviously, this carbon is going to be negative now. This CH is going to be positive now. And this CH3. And obviously, this is going to be 2-degree carbocation because carbon with a positive charge has one hydrogen atom, okay? So 3-degree is more stable than 2-degree, which is why reaction follows 3-degree carbocation according to Markovnikov rule. That will give you the major product, okay? Which is why S will give you the major product. I hope it makes sense to you. Actually, this is unsymmetrical alkene and unsymmetrical reagent. So technically, we can apply Markovnikov rule here, and Markovnikov rule follows stability of carbocation, in which 3-degree is more stable than 2-degree, which is why reaction follow 3-degree carbocation, and which is why S will give you the major product. I hope it makes sense to you. We have done such sort of example in the class. Okay. Product S is formed in a major amount because it follows 3-degree carbocation, which is more stable. Why it is more stable? Positive inductive effect. which is more stable than 2-degree carbocation. Okay. The mass spectrum of R shows peak at mass to charge 150 and 150. So the structure for the ions responsible are, this is R, CH3, CH, CH3, this is CHBr, and this is CH3. We know bromine has, we know that bromine has two different isotopes. One is 79 and the other one is 81. So let me get the mass of each. Hold on. 1, 2, 3. 15 times 3 plus 13 plus 13 plus 79, 150. So that is going to be 150. And this is going to be the M plus 2P, which is going to be 152. So examiner is looking for the structure of ions. So this is going to be the ion. Okay. And obviously, as per my lecture, you need to mention bracket and then positive charge. Okay, because examiner is looking for the ion responsible. And for this, okay, you need to mention positive charge on them, on the bracket. Okay. So that's the whole case. Let's, oh my goodness, that's a huge paper. Figure 4.3 shows a synthesis starting from T, a different isomer of R and S. This is secondary alkyl halide converting into cyanide, which means I'm using sodium cyanide and ethanol, or potassium cyanide and ethanol under reflux condition. This reaction is also called step-up reaction because we are increasing a carbon atom. When acid hydrolysis is involved, CN will turn to CWH. Okay, so that's acid hydrolysis. And in class, I've told you that examiner is going to write this also in this way: H plus slash H2O or H3O plus. If you remember that thing, right? Identify the reagent and conditions for reaction 1. Sodium cyanide or potassium cyanide and ethanol, and condition is reflux. Reaction 2 is a hydrolysis reaction. Construct the equation for reaction 2. So that's easy. Oh my god, we need to balance this equation. Oh, so it's HCl, and obviously we need water because hydrolysis takes place in the presence of water. So I'm going to convert this into C2H5, take into CH as it is. It will turn to CWH. And I've told you in the class that whenever this reaction takes place, ammonia gas is given off, right? So ammonia is basically an alkali. This alkali react with HCl to give ammonium chloride. So the final product is not ammonia. Technically, the final product is going to be ammonium chloride. My God. So we have two ethyl group here. We have two ethyl group here, ethyl balanced. We have CH here, we have CH here, that's balanced. Um, we have one nitrogen here, we have one nitrogen here, balanced. How many hydrogen atoms here, by the way? This is 4 and this is 1, 5. So we need to have 5 hydrogen here. So for that I'm going to write 2 here. So 2 times 2, 4. 4 plus 1, 5 hydrogen atoms, 5 hydrogen atoms, balanced. How many oxygen atoms here? 2. How many oxygen atoms here? 2. So oxygen is balanced. How many chlorine here? 1. How many chlorine here? 1. So it's balanced chemical equation. And that's very, very technical. That's very, very technical. This is the first time examiner is looking for the balanced chemical equation. Otherwise, examiner is always looking for the conversion techniques. All right. V reacts with, okay, V reacts with propane 2-ol in the presence of a catalytic amount of H2SO4 to form organic compound W. Complete table 4.1 to give the detail of this reaction. V reacts, V is carboxylic acid. When carboxylic acid reacts with alcohol, an ester is formed, all right? So type of reaction is condensation, because whenever ester is formed, functional group is formed, ester. Molecular formula of organic product, I believe we need to make the equation first and then we can find out the molecular formula. So we have this compound, my goodness. Okay, let me check this compound. C2H5 taken to CHCOOH plus propane 2-ol. So propane 2-ol is basically CH3, CHOH, and then CH3. Let me get the structure first. In the making of ester, OH is removed from carboxylic acid and H is removed from alcohol. So first of all, let's write it down. The part of acid part, and then let's write it down alcohol part. Okay, there's the structure of ester. Take out the carbon atoms. How many carbon atoms? 2 times 2, 4 carbon atoms. 5, 6, 7, 8, 9 carbon atoms. Okay. Take out the total number of hydrogen atoms. 5 times 2, 10, 10 plus 1, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 hydrogen atoms. And how many oxygen atoms? 1 and 2. So that's the molecular formula of an ester. Okay. I hope it makes sense to you. That's the end of this paper, I believe. Thank you very much, guys. I hope आपको समझ में आया